All right, good morning or afternoon, wherever your class is meeting. All right, so this is section 8.3. All right, so again, we're going to do pre-class. So in number one, you're going to graph y equals 2 over x. And for number two, you're going to find the vertical and horizontal asymptotes. And if you're watching this on Edpuzzle and you have questions, I'm not going to ask you to input your graph for number one, but I am going to ask you to input your vertical and horizontal asymptotes for number two. All right. So go ahead and try these problems. Pause the video if you're watching it by yourself, and then go ahead and check my answer. All right, so for number one, you should have remembered that your vertical asymptote for this basic function always occurs at x equals 0, and your horizontal asymptote always occurs at y equals 0. There's no h, there's no k. So there's 0 and 0. All right, I like to plot these. Here's my vertical, here's my horizontal. All right, then we do a quick XY chart. This one's going to be pretty easy. To the left, we pick, let's pick -2, and you get -1. And let's pick -1, you get -2. And then to the right, you're going to pick 1, and you're going to get 2, and you're going to pick 2, and you're going to get 1. So -2, -1, -1, -2. We know the generic shape of a hyperbola. Connect the dots. 1, 2, 2, 1. We know the generic shape of a hyperbola. Connect the dots, and there you go. All right, for number two, it's a little bit more difficult. So for the vertical asymptote, remember we set the denominator equal to 0. So we have x equals 1. That's your vertical asymptote. For the horizontal asymptote, since your powers are the same here, which we'll talk about in just a second. But basically, it's y equals the ratio of the coefficients, 4 over 1, which equals 4. So that would be your horizontal asymptote. All right, so for today, we're going to go on and graph more rational functions, but now we're going to get a little bit more generic and have more rules. Okay. So in complete generalities, here is a rational function. So a rational function, if you recall, comes in the form of p of x over q of x. And remember, p of x is just a polynomial. Q of x is just another polynomial. Okay. Now this looks complicated, but remember, it's just a polynomial. It's got leading coefficients. It's got degrees. So remember, the highest power is called the degree. Okay. The coefficient in front of the variable is called the leading coefficient. This is the constant term, okay? That's the term without the variables, all that fun stuff, okay? So there are a few things we can look at. Number one, okay, the x-intercepts. To find the x-intercepts of the graph, you always set the numerator equal to 0. So set numerator equal to 0 and solve for x. That will find the x-intercepts. To find the vertical asymptotes, you always set the denominator equal to 0. And then solve for x. And that will find the vertical asymptotes. Okay, to find the horizontal asymptotes, you look at the degrees of the polynomial. The degree of the top polynomial is m. The degree of the bottom polynomial is n. If the degree on top is smaller than the bottom, y equals 0 will always be your horizontal asymptote. If the degrees are equal, then it's the ratio of the coefficients, the leading coefficients. If the degree on top is larger, we do not have a horizontal asymptote. What we have is something called a slant or oblique asymptote, okay? And that's found by taking the ratio of the leading coefficients and then x to the difference of the degrees. And there's a more specific way. You could actually do something called long division. Remember we did a little while ago? So if you long divide it, you could find this, and you get the same answer. And you just forget the remainder. Okay, so I'm not too concerned about that, but that's your slant or oblique asymptote. And in pre-calculus, you'll learn more about that. All right, so here's example one. We're going to graph the function. All right, so just to follow the steps. number one, we always set the numerator equal to 0. Well, guess what? Can't happen. So therefore, there are no x-intercepts. Number two, we set the denominator equal to 0. So x squared plus 2 equals 0. X squared equals -2. Can't happen. That gives me imaginary numbers. Remember, when we take the square root, can't take the square root of a negative number. So no vertical asymptotes. All right. Step 3, we compare the powers. The power on top is 0. The power on bottom is 2. So since m is smaller than n, we know that the horizontal is y equals 0. All right, so we plot horizontal. I picked a point, 0, -1. And you can pick a few other points, but I've done this graph already, and it looks something like this. Okay. So what's the domain? Well, there's no restrictions here in the bottom, right? No vertical asymptotes, therefore the domain is just all real numbers. The range, look at that, it's always below, isn't it? So y is less than 0. All right, example 2. Okay, so same process. So step 1, we set the numerator equal to 0, so we get x equals 0. That's your x-intercept. 2, we set the denominator equal to 0. Looks like we might have to factor. X plus 2, x minus 2, so we get x equals -2, we get x equals 2. Those are your vertical asymptotes. Step 3, the power on top is 2, the power on bottom is 2, m equals n, therefore y equals -1/1, or -1, ratio of the leading coefficients. So plotting what we have here, -2, +2, and -1, and then we're plotting 0. Okay. Now, if I pick a couple other points here, so if I plug in 1, I'm going to get 1 over -3, so I get -1, -1/1, so I get -1/3, so I get something like here, and I'm going to get like this. So I'm going to plug points in, and I get this picture here. If I plug in some more points, so let me pick, if I pick -4, I think I'm going to get, so -4 will be 16, -16, -4 will be 12. So then I get -1 and 1 1/3, -1 1/3, so right about right there. All right, so again, remember we could pick a couple points. I get that value. I'm going to get the same value over here. So I'm just plugging points in, and there's the graph that I get. So there is step 4, really. So you can always plug in points on either side of your vertical asymptote. Okay, plug in as many points as you want to figure out where the graph goes. Tying together that we know that the hyperbola will always approach those asymptotes. Okay. So example 3, we do the exact same thing. So what you want to do always, step 1, oops, let me erase that stray mark. Okay, step 1, you want to always set the numerator equal to 0. This is going to find the x-intercepts. So we can factor. When we factor this, we get x minus 1, x minus 1. So we have x equals 1. Number 2, we want to go ahead and set the denominator equal to 0. X equals -2. Oh, let me go back real quick to number 2. I forgot the domain and range. Okay, so the domain. Okay, notice right here. X cannot equal -2 or 2. So all real numbers such that x cannot equal -2 or 1. Our range is going to be all real numbers such that y cannot equal -1. All right, now back to example 3. All right, so we have this. This is our vertical asymptote. Now we're going to find our horizontal asymptote, number 3. So m on top is 2, n on bottom is 1. M is greater than n, therefore no horizontal asymptotes. In theory, it's going to look like y equals 1 over 1, x to the 2 minus 1, which equals 1 over x to 1. So it's going to look like y equals x towards the end, okay? We'll worry about this later on, okay? I'm only going to worry about this, that there's no horizontal. All right, so we have -2 is our vertical, okay? We have 0, 1 as our x-intercept. And graphing, again, we're picking some points here. So it kind of looks like this. Okay, what I'm just doing here is I'm kind of graphing the line y equals x here. Okay. This is where this comes from. We'll worry about that later. But then if we pick points, we're going to get something that looks like this. Oops. Let me erase this top part here. Okay. It's going to come down. It's going to touch this and come up this way. Okay. And there's your graph. Again, pick points, as many points as you want to get the actual graph. All right, and then the rest of the lesson are your guided practice problems. So again, you should pause the video and try all of these on your own. All right, step 1, set the numerator equal to 0, so no x-intercepts. Step 2, set the denominator equal to 0. X squared equals -2, can't happen, so no vertical asymptotes. Step 3, m on top is 0, n on bottom is 2, m is less than 2, therefore y equals 0. Oh, again, I think I forgot the domain and range. Number 3. All right, domain, all real numbers such that x cannot equal -2. And then the range, there's no horizontal, therefore, all real numbers. Okay. All right, now here, let's actually do stuff here. So it looks like my domain is probably going to be, since there's no vertical, all real numbers. My range is going to be all real numbers such that y cannot equal 0. I'm going to plot this point. When I plug in 0, I get 2. And then when I click a couple other points, I get something that looks like this. All right, number 2. So first step, number 1, we set the numerator equal to 0. We're solving, we get x equals 0. That's your x-intercept. 2, we set the denominator equal to 0. That should be x squared minus 1 equals 0. So we have x plus 1 times x minus 1 equals 0. So you have x equals -1 and x equals 1 as your vertical asymptotes. Step 3, notice m equals 2, n equals 2, so m equals n. Therefore, your y equals 3 over 1, or 3, for your horizontal asymptote. So, domain, all real numbers such that x cannot equal -1 or 1. Your range, all real numbers such that y cannot equal 3. All right, here's -1 as your vertical. Here's +1 as your vertical. Here is 3 as your horizontal. And we know our x-intercept is there. All right, I just picked a couple points and I got this thing here. Picked a couple more points, I got this thing over here. Picked a couple more points and got this thing over here. So again, remember, you just want to pick points on either side of your vertical asymptote and figure out where it goes. No general shape of the hyperbola. It approaches those asymptotes, okay? And then lastly, our final example here, example number 3. I think it's, or I might have example 4 also, right? Yeah. All right, so step 1, set the numerator equal to 0. Solving, you get x squared equals 5, so you get x equals plus or minus the square root of 5. Step 2, x squared plus 1 equals 0. Set the denominator equal to 0. X squared equals negative 1. Can't happen. No vertical asymptotes. Therefore, domain is all real numbers. Number 3, m equals 2, n equals 2, m equals n. Therefore, y equals the ratio of the coefficients, y equals 1. So your range is all real numbers such that y cannot equal 1. All right, no vertical asymptotes. We have a horizontal at 1. Plus or minus the square root of 5. We can approximate that on the calculator. If I plugged in 0, I get negative 5 out. So I think my graph looks something like this. And we can pick more points to be exact if we want it to be. And then last but not least, number 4. Step 1, set the numerator equal to 0. X squared minus 2x minus 3 equals 0. We factor. We have x minus 3, x plus 1. So x equals 3, x equals negative 1, x intercepts. Step 2, set the denominator equal to 0. So x equals 4, vertical asymptote, which means your domain, all real numbers such that x cannot equal 4. Step 3, m equals 2, n equals 1. M is greater than n, no horizontal. Okay. Again, you could, it's going to look like 1 over 1, x to the 2 minus 1, so it's going to look like y equals x as your slant asymptote. I'm not going to be that specific. Since there are no horizontal, you can say the range is all real numbers. Okay. So then for this graph, I went ahead and I plotted x equals 4. I plotted y equals x. Just to help me graph. All right, now if I pick a couple points here, all right, or I can go to the graphing calculator, and that's what I'm going to do real quick right now. So I'm just going to type in the numerator in parentheses. So when you go to the calculator to try this out, parentheses. So I type in parentheses, x squared minus 2x minus 3, oops, x squared minus 2x minus 3 divided by x minus 4. And then I hit graph. Of course, I can't see a thing. So I'm going to hit zoom standard, zoom number 6. And it looks like it goes something like this. Because you're supposed to go through negative 3, negative 1, and positive 3. So it's supposed to come over here. Okay. So let me erase this again. Okay. So it looks like it does something like this, negative 1. And then it comes through here at negative 3, comes back down. All right. And then it probably does something up here, I would imagine, way up there. Again, you can plug points in to figure that out. Okay, example 4. So a carton manufacturer has a large order for rectangular cartons with square bottoms. Okay, so here's a square bottom. Let's call this an x by x square. And then here's a box, and then it's going to have a height of h. Okay, so then the volume is going to be x squared times h, which we know is 6,000 in the problem, equals x squared h. And I'm going to solve for h. So h equals 6,000 over x squared. And I'm going to tell you why in a second. Now we want to find the least amount of material to use. Well, in order to make a box, the material you use is the surface area. So the surface area, well, if the bottom is an x by x, you have a bottom and a top. So you have 2x squared. Then you have 4 sides. Each side is x times h. You have 4 of them, and there's your formula. Now the problem is we have 3 variables. The reason I solve for h is I'm going to plug it into this equation now. So s equals 2x squared plus 4x times 6,000 over x squared. So we have s equals 2x squared plus 4x. Oop, I'm going to actually go ahead and multiply that and distribute. And when I simplify, I get 2,400 over x. Okay, now what I'm going to do is I'm going to plug this into the calculator, and then I'm going to find the minimum of this function. When I do that, I get about 18.17 for x. Okay, and that's how you solve that problem.